Hello, everybody. Welcome. Glad to see you here. Excited that everyone's here at Gear Up at Hack the North 2021. And today I will be presenting the Large-Scale Security Engineering Workshop. So if you're interested in security engineering, stick around. For the next hour, we're going to go over some general large-scale security principles and some things that you might find useful if you yourself end up going into security engineering. So here we go. Hello, everybody. I'm Katya, and I'm a computer science student at Waterloo who does a cappella in her free time. Also, before we start, keep in mind that you can ask questions at the Slido link at any time. I'll be checking it periodically and answering questions throughout the workshop as well as at the end. Cool. And a little bit about my background in security engineering. So I started off in security engineering back in fall 2019, where I took a research role at the Singapore University of Technology and Design. And there I was working on a machine learning model that was detecting cyber attacks conducted on a water treatment system. So mainly dealing with cyber physical systems there. After that, in winter of 2020, I went on to work at Abnormal Security, which provides a cloud-native email security platform. And I worked on the infrastructure team there as a software engineer. Then, fall of that same year, I joined Datadog as a software engineer on the community team. And we mainly dealt with open source projects and facilitating Datadog's various workshops and presentations at different conferences. So I was working on a Capture the Flag event for reInvent, which is AWS's big yearly cloud computing conference. And we had around 1,700 attendees there. So that was really fun. And then after that, I went back to Datadog as a member of the cloud security team. There I worked on a resource scanning service and policy enforcer. So if you're curious about any of that as well, feel free to reach out to me. I'd be happy to talk more about my experiences at those different companies and teams. Had a really good time at all of them. That's kind of why I'm here today talking to you about security engineering. Learned a lot. Cool. So I'll just go through the agenda real quick. Maybe make my face a bit smaller there. So first off, we'll go through a quick intro to security engineering. And then we're going to spend around 20 minutes scaling up our security principles. So that's the idea there is we're going to start by looking at how to secure a single resource, 2 resources, then move on to 10 to 100, and then on to thousands of resources. After that, we're going to look at 3 different tools that I've worked with and found interesting. And these are security tools that are used for large-scale security engineering. They each have a very different purpose, and I'll be happy to answer any questions as we go through those as well. And at the end, I'll take any further questions and just sum up what we've done today. All right, so start off with a quick intro. What are our goals and motivations as security engineers? Now, to preface, you don't have to be a security engineer to go into the cybersecurity space. There is so much for you to do here. You could go into risk assessment, threat intelligence. There's a lot of work to be done in training and awareness. And security engineering is just one small branch of this whole ecosystem that makes cybersecurity possible as we know it today. So today we will be focusing on security engineering, but just to be aware, there are lots of branches there that you can take. Now, software engineers, what do they do? General definition, they use principles of computer science and mathematics to build programs, platforms, and applications using software. Essentially, they build systems, something like what you're seeing on the screen right now. So security engineers, in contrast to that, will monitor those systems and make sure that there aren't any security breaches, and they'll periodically test and screen the software, make sure that everything is secure from any adversaries that might want to take advantage of that. We'll touch on that, go a little bit deeper into that later. So security engineers protect those systems, and usually it's by designing systems of their own. So sometimes security engineering is not too far removed from software engineering. You can often automate these systems. For example, here this diagram kind of depicts that you can secure each component of a system on its own, and you should, and then also have some sort of overlay onto everything, some sort of system that perhaps contacts each resource and does some sort of scanning or some enforcing. Um, Generally, both of these steps will be done for best kind of security in a large ecosystem. But that's kind of what security engineers do, is they'll make these applications that serve your entire ecosystem, and like they're going to look at a kind of like the broad scale security of your ecosystem, and then they'll also go more into depth and see what can be done for each specific resource or each specific connection or network subnetwork, and kind of see what can be improved there. So there's sort of like there's a bottom up and a top down approach there. Okay, so what are we securing? For the purposes of this talk, I'll be talking about resources, which generally are any hardware or software that's accessible by a computer, network, or another object connected to a computer. And adversaries will seek to access, manipulate, or terminate our resources and the data they store. So resources, as you can see, they're pretty general. It's a pretty general term. We can look at many different kinds of adversaries. There's amateurs who are just poking around and they want to see what can be done, kind of test the limits. There's also script kiddies who are potentially also amateurs, who will download malicious scripts from people who are very skilled and experienced in cybersecurity, breaking into systems, but they themselves don't know a whole lot. There are adversaries who are parts of organized crime, so they might benefit financially from breaking into systems. A lot of phishing attacks will come from this form of crime. Then you have government cyber warriors who have a strategic interest, and terrorists who have a political interest in breaking into your system. And this is a very short list, so there are a lot of people out there who are looking to get the very valuable data that is stored in your resources, or to somehow alter, manipulate, or take down your system. So big scary world out there. Let's look at how we can secure our resources. So we're going to start with one single resource. We'll represent it by a treasure chest, because maybe that's what it looks like to an adversary. I'm not sure. The resource could be a computer, a communication device, a computer system, or a database. We're just going to look at computer system, and for our purposes, we'll just look at the client-server architecture that is used for a lot of apps out there. So what is a client-server architecture? Just a quick overview, even if you've heard of this before or familiar. You can think of it as a restaurant. So clients are the members, the people who come into your restaurant, the customers who are looking to have food served to them. And the servers are the waiters who are going to come, or they're literally called servers in restaurants. So they'll come by the client's table, ask you what you want. The client will tell them, and then the server is going to go back to the kitchen and get the client or the customer what they asked for, whether it's food or drinks or whatever. A poorly designed client-server architecture might feel like a restaurant that runs inefficiently. For example, a server who comes by your table and asks you, "Hey, what can I get? What can I start for you? What can I get you started on?" They'll ask maybe one member of your table, and that one member responds with a drink, and then the server leaves. That's not a great set up because nobody else has received any form of nourishment at this establishment. So this could be compared to a very inefficient server that takes a very long time to serve data. Uh, Anyways, so that's a general overview. So in this model, the clients are the user's laptop and desktop computers, tablets, and smartphones, and the servers are the computers that serve their data and applications to one or more clients. It's a fun little diagram. Okay, so how do we secure a server? It is a lot easier for us to secure a server when, or it's a lot easier for us to secure an app when we've set it up within a client server architecture, because the server mostly owns the information that you're serving, and they are responsible for enforcing any sort of security that you need to have on your app. So servers should use an SSL certificate to ensure the traffic is secure, first of all. And SSL stands for Secure Sockets Layer. This is a standard security technology, and it enables encrypted communication. So encrypted communication is basically like two computers talking to each other, but nobody else being able to understand what they're saying because they've kind of set up this secure connection. And in order to create that connection, you would install an SSL certificate onto the server. And the SSL certificate, first off, authenticates the website. So it tells people that, this is the website that it claims to be, and it's not just some random bogus knockoff website. And secondly, it also encrypts the data that's being transmitted. So SSL certificate is first thing you should do. Second is you should have a firewall between the server and the client. So a firewall can track the connections that are being made between the server and whoever's trying to connect to it. And if you have a good firewall set up, you could potentially avoid a denial of service attack or a DDoS. This is a kind of attack that occurs when one or more of your clients is spamming the server with requests, and this might prevent any other clients from receiving any form of data. So, it's like let's say like going back to the restaurant analogy, somehow you've set up a restaurant where you have, it's possible for a customer to come in and keep ordering things, and they're going to say like, yeah, I want this drink, I want that drink, and they keep ordering, and the restaurant only serves them because they're asking for food much more than any of the other customers in that restaurant. So these are fairly common attacks, and if you set up a firewall, you can prevent DDoS attacks from happening by potentially limiting the number of requests that can be made from any given client. Or there are different approaches. It's pretty. I think it is pretty big field of research right now. Third is to have a separate database for storing data. So, and you should store passwords in the database with a secure hashing function. So, something. It's pretty essential. You shouldn't store your passwords in plain text. You should always hash them before you store them in any database. And this prevents, even if attackers gain access to your database, it may prevent them from revealing the passwords and potentially compromising, thousands or millions of accounts. Now, so we've talked about the server. So how do we secure the client? Well, if our server is well secured, our client shouldn't really have to do anything besides securely connecting to the server. And this will be the server's responsibility to make sure that authentication and authorization is done well. We touched on this a little bit, but let's just talk about authentication versus authorization. So authentication means proving that you are who you say you are. So we've got a little fun dialogue here. Got Freddie trying to confirm to this cow that they are who they say they are. The cow, let's say the cow's name is Fred. The cow says, "What did we eat for dinner last week?" That's something only known to Freddie. Freddie says Lizzie's on the rocks, and then Fred says, okay, nice, you really are Freddie. So that's authentication. Fred has confirmed that Freddie is who he says he is. Is it a bad way to confirm that you are who you say you are by asking what you ate for dinner? Maybe, but that's besides the point. Then authorization is the process of giving permission to access a resource. So now that Fred has confirmed that Freddie is who he says he is, he can let him into their apartment. It's not a problem. But you have to make sure that when you're designing an app, your authorization always follows authentication. So if you authorize somebody before you even know who they are, it could be anyone. It could be malicious, someone who has malicious intent, or someone who really shouldn't be accessing the resource that they're trying to. And yeah, I see we have a question in Slido. So I'm sorry if I mispronounce your name, but Ibtihaj says, what are the main tools a person should know to get into security engineering quickly? That's a great question. So I think, let me just think about that, because there are a few different ways to get into security engineering, and it's not, uh, I would say, like, for me personally, I didn't really know any tools going into it. I also started off in internships. So I was given the opportunity to learn tools as I went along. But, I never did capture the flag challenges. I didn't really have extensive experience designing any secure apps before going into this. Um, but I would say, first of all, that the mindset is really important. So when you're interviewing for a job in security engineering, um, your employer will probably ask questions along the lines of, basic sort of authentication protocols. I'm not sure if they might. They would probably ask you something like how would you design something securely? And the idea behind secure design is that you are not necessarily moving fast and breaking things like the Silicon Valley, the classic line goes, but you also don't want to go too far into um, over designing your security protocol. So somewhere in between. Um, I don't know if this is making any sense, but I would say having a good understanding of what I'm going to talk about next, which is designing or being as part of a security team that is designing systems that are usable by developers and that aren't overbearing. So that's the first kind of thing there. To give you an example, if you were to say, I want everything within my organization. If I were to join your security team, I would want everything within the organization to be secure. I would go into every resource and make sure that these particular protocols have been met and that we're following this standard. I'm not sure that that would be the best approach. I think that some of the more sort of recent paradigms in security engineering involve sort of paving a road for other engineers to make things secure by default and make it secure easily. In terms of tools that you could look at, I can link a couple of frameworks in the chat that might be of interest to you, but I'm just going to do that at the end of the workshop, if that's all right, because it'll take me a few seconds to pick it up. Yeah, Chris mentioned a few CTFs there. Okay, I think CTFs are very useful for gaining an intro to security engineering and kind of learning the basics. But I wouldn't recommend it as your only method of preparing for your career, because CTFs tend to focus more on breaking into systems, and the process of completing a CTF may overlook certain vulnerabilities that are really common and may potentially be a lot more destructive than the kinds of challenges that are presented to you. But I think they are really, really useful, and that you're going to learn a lot from them if you do decide to engage in those. So I hope that answers your question. I know I kind of rambled a little bit, but feel free to ask any follow-up questions, and I'd be happy to answer them. Chris says Hack the Box Academy has a pen testing pathway where it shows you what tools and reports you need to generate. Oh, that's pretty cool. So that's yeah, I didn't know that. Pen testing is a very cool kind of avenue because you get to do the kind of work that you get to break systems as opposed to building them. And if you like the idea of that, you should definitely look into that. I'm not a pen tester. I'm on the other side of things. I usually build the systems and just look for security vulnerabilities, but it's a really cool space. All right, I'm gonna move on to the next slide here. So we're gonna scale up to 10 to 100 resources. And this is, I'm just gonna talk about network security here. So we have a few kind of principles that we go by when we're looking at, sorry about that, just having a bit of technical difficulties. All right, sorry about that. Yeah, so secure networking should encompass 5 different principles. And this will be pretty high level. So first of all is perimeter security, which protects applications from outside attack through firewalls. We talked a little bit about firewalls earlier. We can also use intrusion detection, which involves setting up some sort of app that can detect if your security has been, if your network has been compromised. So that's pretty cool space to look at. Then there's communication security, which provides data confidentiality, integrity, and non-repudiation using SSL or VPNs. We talked about SSL as well. And this is this kind of touches on privacy as well. Privacy is a very different topic that I won't get into, but sometimes there's a bit of overlap. Then we have platform security, which ensures that each device is available to perform its intended function and doesn't become the network's single point of failure. So this could include antivirus checking, and we can also look at installing intrusion detection tools on a host. So something that checks perhaps what kind of recent connections have been made to any particular resource, or what files are currently being modified. Those are 2 examples of something that kind of app might look at. Then we have access security, which ensures that each user has access to only network elements and applications required to perform their job. Now, this is a big one that is also often overlooked. There are a significant amount of attacks that occur from within organizations. So sometimes people have different motivations for being within an org, or their motivations change as they work within any given company. And there's a significant, there's a big market now for looking into tools that prevent people from conducting attacks as they're leaving a company, for example. Something that might be called a revenge attack. Someone is perhaps not super happy with the way things are run and decides to do something with the access that they have within that company, try to upset some things. So that's a pretty common one, and it's very important that each user only has access to what they need. Oops. And lastly is physical security. So this will encompass everything. Everything runs on physical servers, and it's important to make sure that those are secured. So if you're running entirely on a cloud computing platform, this probably won't be a super huge concern for you, but it's also important to make sure that everyone's personal laptops or work laptops, whatever you use to connect to your app, is also kept secure. So this is like locked doors and alarm systems. We have another question. It's from an anonymous asker. The question is, would scaling innovative cybersecurity solutions be limited by always existing advancements in social engineering? That's a great question. So, yeah, it depends on the class of solution that you're looking at. And there are a lot of solutions that are currently being worked on for social engineering in particular. So, I can speak from the email security side of things. Phishing attacks are super common. They're the number one way that small businesses are compromised. You might think that your spam filter is going to get most of those, and it's fine. Like you wouldn't fall for that anyways. There are attackers have very sophisticated techniques for masking their identity, um, creating a domain that looks very similar to your company's domain, and also using different social principles to convince you that they are who they say they are. And if you're not familiar with the idea of social engineering, this involves um, kind of kind of like rigging your psychological system or any person's sort of psychological framework for working within a company, kind of abusing that to gain access to some piece of data they have. Some tactics that are used are urgency. So, someone in sales receives an email from their CEO saying, "Hey, I need this. I need $500 in these gift cards right away. This is super important. Um, you've been looking at that promotion. Like this is your chance to make it to shine." A bit of a contrived example, but um, people respond really well to those because the urgency doesn't give them the chance to run all of the checks in their mind to make sure that this is really the person who they say they are. So that's one example, and another one, of course, accounts can be compromised via um, simple pages that are asking for your username and password and that look like the websites you're used to. And oftentimes people won't notice that they've logged into a website one extra time than one more time than they actually had to, and that website um, is actually a phishing website. Something that occurs. So some of so to answer the question, some of the technologies that we looked at were machine learning solutions that would look at the way that words are structured and use that in combination with the kind of the background of the domain from which the email is coming from. You might look at the length of time as well that the domain has been registered. So typically, domains that have been around for a shorter amount of time are a little bit more suspicious because it's possible that they had been shut down before for carrying out similar phishing attacks, and just started back up again. So new domains are pretty suspicious. There's different kind of combinations. Abnormal security in particular had a COVID-19 specific category. So they looked at some of the phishing attacks that were carried out that were specific to COVID. What do you call them? Like the checks from the government, like the COVID checks. A lot of attackers were abusing that as well and telling people like abusing the lack of information that people had about COVID and saying, you have a check waiting for you, come grab it now. So yeah, the technologies are um, there. It's very hard to keep up with the tactics that are used, but it is possible, and I think especially with kind of NLP advancements, it is possible to kind of keep up with that with increasing levels of complexity in social engineering attacks. I think I think it will always be a problem. Like it's kind of like each side is coming up with new and different attacks, and I don't think anyone is going to win out ultimately. It's just a matter of being as aware as you can be of your adversary and what kind of tactics they're using right now. It's a great question. Um, all right. So next we are going to look at the last in my slides of security engineering, scale of security engineering. And this is, thousands, tens of thousands of resources. I'm going to grab a sip. Excuse me. So now we have thousands of resources. How can we possibly manage all of these by ourselves? Before we were looking at, specific connections, we were looking at particular resources, but we can't really do that on this scale. So first kind of instinctual answer is to automate things. And this is a very, very good strategy. Whatever can be automated should be automated. So something like, certificate refreshes, perhaps checking on the number of connections or the number of requests that have been made from any particular client, blocking clients when they've exceeded a certain number of requests. Just a few examples of automation. You really shouldn't do anything manually that you can automate. It's usually worth it to do so. And this is as you scale up, of course, and you have the resources for it. You automate things where you can. But the next point is to introduce secure defaults, and this is called a paved road approach. So it's kind of the idea is you've paved a road for developers to design apps securely while not spending a lot of time thinking about it. Because typically, if people have to think about security, they're probably not going to do it. It's probably not in their list of priorities. And it's a very, very good thing for an organization as a whole to do. But for a specific developer working in a specific team who has their own deadlines and their own priorities, they just want to get it done, and they don't necessarily even have the background to design things as securely as would be ideal. So paved roads. You can train people as well. And this is always a good idea. It's good to remind people of what good and bad practices are. But even better approach is to eliminate entire classes of flaws by using libraries that are secure by default. So, and let me wonder if I can just post a link in the chat, because this relates to the question that was brought up earlier. And I'll just take a quick break. Yeah, here it is. Let me see, can I post that there? Yeah. So that whenever that gets posted, I'll go over it real quick. It's this is just a blog post. It's called A List of Secure Defaults, and it's by Abhay Bhargav. Just describing some frameworks and libraries that you can use that have secure protocols, secure practices implemented by default. So this relates to Ibitajit's question earlier about tools that you might want to look into to get into security engineering. So if you scroll all the way to the bottom there, there is, I can actually just share this, can't I? So you have here, libsodium and Google's Tink for cryptography specific libraries, and then for client-side output encoding, DOM Purify and Bleach. And you can go on. I would recommend reading through these, and if they are open source, if the issues are public, it's a really good practice, a really good idea to look through the issues and see what people have brought up and what's been solved in the past. So it's kind of, it's a good way to, well, let's look at Bleach, for example. So if we look at the issues here, and we look at some of the closed issues, we can see, yeah, some of these. are fine. Oh, we can look at a feature request here. Clearing the unvendoring policy. It it might take a little time to onboard onto these systems and read through them and understand exactly what this means, because I'm not too sure what they're talking about here as well. I'm not familiar with Bleach, but you know it is by Mozilla. It's well maintained, and this is a great way to see um, how work is done within security teams, or teams that are working on projects relating to security. Looks like they just updated some docs here. Yeah, so that's just one approach. Good for your own personal understanding of how security engineering is done. All right, so that's those are the secure by default, some of the secure by default libraries there that I linked. So anything relating to managing secrets, again, authentication, authorization, SQL access, file system access, and those in particular are subject to SQL injections. If you're familiar, that's kind of the attack where you can send input that renders that does what it. You can send input that changes the way that the code is executed. So instead of looking up the customers, maybe you've sent some weird quotes or escapes that have enabled you as a client to see the customer's credit card numbers. I don't know. Um, so anything that makes that impossible by default is good. Okay, next. Introducing a bug bounty program. I mentioned this just real quick because bug bounty programs are a fun way to get involved in security engineering as well. There are a lot of resources on YouTube for people who are interested in that, and that's basically it's a program that pays people to discover bugs in an app. So most fairly large tech companies will have these. Google has one, Shopify has one. I don't know why those two came to mind first, but there are a lot of them out there, and they'll kind of give you details of which websites are in scope. So if you find a bug that is in scope for that particular organization, you can join their bug bounty program, send them the bug, and depending on the severity and how I think depending on the severity, basically you'll get paid a certain amount of money for having discovered that bug. So it's pretty fun. And fourth, you can run penetration tests. So penetration testing is a simulation launched on your computer system that helps discover points of exploitation and test security. So consistent pen testing will give you the ability to avoid extremely expensive and damaging breaches. And they're not the same as vulnerability assessments. So you can do kind of like an assessment of your entire ecosystem and see. It's kind of like a scan. You're just seeing what's going on in the system. Penetration testing is a simulation of a cyber attack. So you have to be careful with these, because if you do them and your system goes down, um, it's not, it could have been, maybe it was a very severe security bug and actually caused the kind of damage to your system that an attacker would have wanted to cause. So just be careful when you're running these. I personally have almost, it wasn't that big of a deal. Like I just ran, um, I think it was a fork bomb on my computer and nearly crashed it. Not that big of a deal, but don't run that on production servers because, um, yeah, you're not sure if your customers will be too happy that your security engineers have taken down your service. And lastly, you can introduce runtime monitoring. So this helps you detect security vulnerabilities live as your app is running. Here's a diagram. This is from Clint Gibler's talk. It's a really good one. It's called How to 10x Your Security Without the Series D. And I'll credit him at the end. There's a newsletter you can sign up for that deals with security, engineering, and kind of like the latest best practices. He's very knowledgeable and releases a lot of good content. And so this is just a diagram of what kind of tactics you would want to use for different classes of vulnerabilities. So for easy vulnerabilities, you want to basically rely on secure defaults. And I think sometimes the instinct is to focus on automation as the solution. Automation is not always the best way to go because that involves maintaining tools that like the tools that automate your processes. Whereas secure defaults, um, they're defaults. They're there, and um, it's better to completely avoid uh, security vulnerabilities or any classes of security vulnerabilities from the get-go. Um, whoops. It's better to avoid certain classes of security vulnerabilities from the get-go than to go ahead and later, automate a process that shuts them down or fixes them. So as soon as you can detect, the sooner you can detect these vulnerabilities, the better. Okay, now I ended up going a bit over time, but okay, let's go through some of the questions in Slido real quick. So Anonymous says, isn't it easier for an adversary if we automate it though? I'm not sure what you mean by that exactly. If you mean kind of that it's easier for an adversary to understand how your system might have been automated and to then get around that, that's what pen testing is for, and that's what bug bounty programs will be for as well. So a lot of, and also the adversary typically doesn't know exactly what you've automated. So it's not good to rely typically on adversaries not knowing things to secure your applications, but security is not absolute. There's a lot of evidence that shows that quantum computers are eventually going to undo all of the encryption that we're currently using to secure everything. So it's it's basically just an arms race of who can make things hard, or if you can make things hard enough that people aren't going to attack that resource, then you're good to go. And automation makes it harder because you can make sure that certain endpoints are closed off, for example, or you can make sure that certain types of requests aren't being processed. So yes, an adversary might take note of that and notice that there's automation behind this particular kind of attack and then go a different route. But we've already slowed them down, and that's good enough for us. David Wang asks, what is the difference between a vulnerability test and a penetration test? So I think a vulnerability assessment, typically your vulnerability test will go through your entire ecosystem, kind of just scanning for vulnerabilities. So it's more of a general, it's a general approach to securing an environment, and this typically doesn't get some of the more tricky or complicated compromises that can take place. So it's kind of like a vulnerability test will tackle some of the easy to medium um, potential compromises, whereas penetration tests are going to tackle the hard ones. And penetration tests are, typically run by humans. Vulnerability tests can be done; they can be automated, and that can just be done by some script that checks that, for example, each resource fulfills these particular requirements. Penetration tests that's like a human who is scanning through resources and saying, okay, what can I exploit here? What can I attack here? Anonymous asks, can ethical hacking be limited by the regulations and structures imposed on it? Would malicious processes be needed to ensure that loopholes or breaches are stopped? I'm not familiar with regulations on ethical hacking. I know that bug bounty programs are limited because there are I'm sure there are certain services that are in beta that probably have a lot of security vulnerabilities that just maybe might not be worth it for a company to include in their bug bounty program. I'm just spitballing. I don't know if that's actually true, but I don't think so. I don't think you would need to do something malicious to make sure that loopholes are stopped. I think it will be exploited eventually, and it could be. It's definitely a point of concern for companies, and it's something to keep in mind for security teams that if they've left something out of scope, that particular service could be at a greater risk than others. But no, I don't think it's necessary at all. Um, Again, it's kind of an arms race. So if a malicious attacker gets to it before your automation does or before your pen tester does, um, that's there are a lot of different ways to approach solving that, depending on the kind of compromise that's taken place. All right. So I will do a. I'll go through a few cases here. So the goal here is to familiarize people with some of the tools that you could use as a security engineer that you might find yourself using and that I found myself using in the past. So, oh my goodness, that's not the right. I'm gonna just fix that real quick. Technical difficulties. Sorry about that. Okay, this is the right one. Okay, so first off, I'd like to show you the machine learning system that we used in SUTD. And this is with the iTrust team in the SWAT lab. So basically, this lab has a fully functional water treatment system that um, people run attacks on regularly. And these attacks are monitored and data points are taken to then do further research into the kinds of attacks that can be conducted on industrial control systems, which is, if you read that abstract there, these are systems that, oh, they don't actually give a okay, yeah, if you look at the introduction here, there's a bit of a definition, but industrial control systems typically deal with that typically includes public infrastructure such as power, water treatment, and transportation systems, and they're particularly vulnerable, particularly at high vulnerabilities within these systems are particularly high risk because these systems typically provide core services for residents of a city or certain county or area. So these systems have the one that I worked on. The way that it was set up was that you had a bunch of sensors, and I'll show you a diagram of what they look like, but a bunch of sensors that connect to a SCADA workstation. And SCADA stands for Supervisory Control and Data Acquisition. So this is a centralized workstation for administrators of the system to see what is going on and to check on the different sensor values and make sure that the system is working correctly. And if you can potentially penetrate a SCADA workstation or compromise the connection that it has to any one of the sensors within the system, that is pretty. That's pretty high risk. That's kind of you've got kind of got a single point of failure there. And these systems have to be set up this way, I think. But the way that they're set up typically there needs to be one place for people to see what is going on in the whole system. So look, we're just going to go on a bit, and if you're not familiar with if you haven't read an academic paper before, this might seem a little bit overwhelming, but I would encourage you to get into the habit of that if you're looking into cybersecurity, you don't have to understand everything. I usually read the abstract and then have a decent idea of what's going on. And if it interests me, I might then go into the actual methodology and try and understand how the system works, or what exactly the research was that was conducted. Um, but yeah, kind of typically just reading the abstract is a great start. So, let's look at this one. So, here we're talking about industrial control systems. They're critical to any society. Process anomaly detection mechanisms have been proposed to protect such systems to minimize the risk of damage or loss of resources. So, a mechanism that has been proposed to protect these systems. That's what we're talking about here. So this particular paper looks at a graphical model-based approach. Model-based here referring to machine learning model. So this is proposed for profiling the normal operational behavior of an operational ICS referred to as SWAT. This is the water treatment facility that is set up in the lab. So and then it talks about the two models that are used here, timed automata and Bayesian networks. Um, Again, this isn't a machine learning workshop. You don't have to know what these are in detail. But so these two models are used, and their results are combined to provide the most coverage possible for this particular industrial control system. Just grab a drink. All right. And if we skip ahead a bit here, experimental results demonstrate the model's superior performance on both precision and runtime over methods, including support vector machine. Again, just general idea here is that they have experimental results, and we can scroll down and see what those results are and kind of how they were generated. That's a good, valid, or before assessing whether it's a good research or not, or anything like that, just to see kind of what has been claimed in this paper. And yeah, so the underlying idea is generic and applicable to other industrial control systems such as power and transportation. Yeah, so let's look at how this particular system is set up. And so over here, here's just kind of a visualization of the, oh my goodness, why does it keep switching? So sorry about that. Switch back here for a sec. Okay. There we go. Sorry about that. So it seems like whenever I rescale it, it kind of trips out a bit. So over here we have the layout of the plant. And so if you see these codes here refer to sensors, and each of these sensors output data. So there are, and this diagram just depicts in dotted lines the different stages of processing water. So, generally, it's kind of a linear process. And the interesting bit here is that any one of these sensor values could potentially be modified to display something or output something other than what it actually is. These were the particular kinds of attacks that we looked at when or that the researchers looked at when designing the system, and the ones that I looked at when I was improving it. So for example, let's say LIT 101 here with the raw water tank. Let's say that one has 10 liters of water in it, but an attacker's gone in and said, well, actually, there is 1 liter of water in this tank. So, now we have a little bit of inconsistency in the system, and this 1 liter, let's say they manage to broadcast that to the SCADA, the central system, and also to some of the other sensors. So, but typically the SCADA will kind of monitor, how much water is going where. So the SCADA sees, okay, it looks like this tank has 1 liter. Let's just pump that all through, and we're gonna keep processing it here, until we get to the static mixer here, let's say. And it pumps what it thinks 1 liter of water, what it thinks is 1 liter of water, um, and then it it stops. But there's actually another 9 liters of water left here that aren't being treated. So you could eventually end up with a situation where perhaps there's a rupture in this tank, perhaps there's an interruption of service, or something else. I'm not too sure how the water system could be compromised in particular, but um, so the machine learning model kind of takes care of that, and that's the uh, sort of fun part about machine learning, is that you don't necessarily have to. You should, but you don't necessarily have to know exactly why it's doing what it's doing. You can sort of see what your results are, and sometimes you can sort of reverse engineer, and you can see, okay, like you can draw some conclusions based on um, what kind of models performed well on your data set. Yeah, feel free to ask any questions you have about that. Um, but that's that project. So again, yeah, I would encourage you. Okay, well let's go into evaluation before moving on. So this talks about how this particular data set was evaluated, and there's some interesting content here on how the machine learning algorithms are set up. And this will take a little more time to kind of analyze, but if we can go, perhaps we'll see it in the conclusion. No, not the conclusion. Yeah, it'll be a little further down in the evaluation. Okay, so I think we have it here. CP and PS. There are lots of acronyms, and typically, sometimes they're defined in the paper, sometimes not. You might have to look them up. But you can look at, kind of the probabilities that any given method will yield a good result. So what it looks like here is, I think we're gonna go a little further to see what the results are. Here we go, results of each model. So this refers to, it looks like they tried 16 different models here in this paper, and each model detected a different scenario, and each scenario is an attack that was carried out by someone doing research on this framework, on this industrial control system. So it looks like they've enumerated 35 of them here, and each model has detected, these particular scenarios. And we can look at, which combinations of models would yield the best coverage, and kind of see, you know, you can go back through the paper, and there might be a discussion on why this particular model detected these scenarios, or not even why, but how usually is a better question to ask, because you don't always know why. Anonymous is asking, how would the ML algorithm know that 9 liters are left? So the algorithm itself wouldn't know. Thank you. I should clarify that. The algorithm that we're talking about here doesn't um, actually control the water treatment system. It monitors the data points that are coming out of the sensors and attempts to detect if there is an attack going on right now or not. And so the ML algorithm would know, it would see like anomalous behavior, because typically in a water treatment system, you'll have some sort of cadence where you have a certain amount of water that comes in, and then some kind of repercussions from that water coming in. maybe in this case, the algorithm might detect, okay, well, there was 1 liter moved through, and we think there's 1 liter, there's 1 liter being outputted from the sensor, but it looks like there, there's a lot of water coming in through the initial, and we can detect this through the initial sensor, but then that water isn't being detected at LIT 101. So, that might be a signal to the model that, or that might kind of be a pattern that is recognized within this model as an attack. And this is important. Yeah. So if going back here, like let's say FIT 101 detects another, or it has detected 10 liters of water, but LIT 101 is only detecting 1 liter. That could potentially be a signal that LIT 101 is leaking, and not necessarily that there is an attack going on, but it is suspicious, and so it could be marked as an attack. Anonymous says, could these hacks be prevented if the system was totally isolated from the internet? So, a good class of a large class of attacks could be prevented, yes. Mm, but that might come at the cost of ease of use by the administrators of the system. So if you're not connected to the internet, um, you know, you could set up something locally and it probably would be fine. I'm not sure what kind of tools might be used by people maintaining these systems, or if they need a regular internet connection to keep those tools up to date. Um, but even and actually, I do believe that this particular system was not connected to the internet, so they had their own network, and this network is pretty. It's a lot better that it's not connected, but there there are significant there's a significant risk from physical security breaches. So, for example, someone coming into the system and physically attaching a cord or a connection to their computer. Um, and there was actually a whole entire research team that worked on developing a VR application that would train security teams that were responsible for monitoring these plants, and kind of like detecting and seeing where people can kind of compromise the system. So it's it's still possible. Anonymous says, are the different scenarios predetermined? Yes, they are collected from yearly events that this particular lab runs, and they I don't know if it's paid or not, but I know it's a very big event for the cyber physical security space, where researchers will come in and they'll basically pen test the water treatment system, and then their tests or their attacks are recorded and then used to classify the data points that were collected during those attacks. So each kind of set of data points, each range, would have a bit, and if the bit was on, it meant that an attack was currently going on. And I believe that's where they extracted those 35 examples from. Yeah, thanks for the questions. We're going to move on to our next system here, because we are running over time, and if you have to go, feel free to go, but we've kind of gone over all of the major points that I wanted to touch on for large-scale security engineering. But we're going to go and look into these these second two tools real quick. The next one I wanted to introduce to you is called Atomic Red Team, and they actually have a very friendly ecosystem for open source contributions. So you can join their Slack workspace, and they'd be happy to help you out there if you're looking to contribute to this repo, or if you're interested in security engineering in general. They also run, I believe, what are called Atomic Red Fridays, where people come in and do talks for the Atomic Red Team community. I don't know if they're still. I know they were running those a year ago, but yeah. So This is one of those repos where you can kind of go into the issues if you're interested in seeing. But this particular repo doesn't have any code. It's all defined in Markdown format, and this is a collection of tests that are mapped to the MITRE ATT&CK framework. So if you're unfamiliar with MITRE ATT&CK, I'll just kind of show it here. So it's a knowledge base of adversary tactics and techniques, and it's organized here by what we can see is just scroll it. It's a left to right classification of different stages of attack. So we start on the left with recon, so collecting information about attacks that can be carried out on an ecosystem. And then we go into resource development, developing accounts and establishing permissions that you might need to carry out the attack. Initial access, execution, persistence is sticking around, is kind of making your attack stick and not have your account lose its credentials right away, for example. Yeah, and it goes all the way here to exfiltration, which is I believe exfiltration is the process of sending out the data that you have breached or that you've gained access to. Oops. And then impact. So that's removing accounts, removing data, preventing organizations from knowing how and where and why the attack was carried out. So it's very comprehensive, and each one of these steps has different list of potential techniques that can be used for that particular step. And just to show you how you can use this in conjunction with Atomic Red Team, let's, if you're interested in seeing any particular technique here, you can comment it in the chat, but otherwise I'm gonna just pick one. All right, so let's look at I could pick any one of these. I'm just kind of curious. Okay, gather victim identity information. So this attack involves gathering information about the victim's identity, and that can be used during targeting. So we have an ID for each attack here, and if we go back into the Atomic Red Team repo, we go into Atomics. Here's a list of all of the attacks classified by their IDs. So let's just find, hello, Control F. Oh, okay. I guess there aren't any for that particular attack. Let's pick a different one. Let's see something a little earlier in the process. Establish accounts, perhaps? Some of these aren't, don't have a clear mapping. I don't know if I'm just, maybe I am doing bad search on this. Because right here we've got the ID T1585. Interesting. I've just happened to pick two. Out of all of the possible ones, I've happened to pick two that don't have a match here. Let's pick one at random then. All right, T1037.004. And the description is going to be here as well. This is pulled directly from the MITRE ATT&CK framework. So, okay, RC scripts. So, what are these? This looks like it relates to persistence. So, adversaries can modify RC scripts, which are executed during a Unix-like system startup. And these files allow system administrators to map and start custom services at startup for different run levels. They require root privileges to modify. And root privileges is like it's the biggest, it's the most access you can have within a system, within a Unix system. So it's very clearly, everything's kind of very clearly described here. And you see several Unix-like systems have moved to systemd and deprecated RC scripts. In Mac OS, this is deprecated in favor of launched, but some older systems can still execute these. And a lot of servers will run operating versions of operating systems that are fairly out of date because their focus is on just staying up and staying up as long as they can. So if you don't need to update an operating system and you don't need to potentially cause downtime in your servers, it might not happen for many years. And so here we see Atomic Red Team actually gives you the attack commands that will tell you or that will execute the attack or the stage of the attack. And it'll also describe what, some of them will describe what the expected output is if the attack was successful. So yeah, if you look at rc.common, so if you can modify this particular RC script, you can see this is just it's a pretty basic echo command that then is written to RC common. So if this actually happens and succeeds with the 0 return code, then you know that it's possible for an attacker to do this. And I should mention, when you're carrying out these attacks and you want to see if an attacker can do it, you should use them with the privileges that you think an attacker would be able to gain in your system. It doesn't really make sense to carry out these attacks and be a root user if you've done a lot of um, if you think that it's not very reasonable for attackers to gain access to root. So that's kind of an example of what you can do there, and it's very readable. So I would encourage you to look into that. And you can use this. I think these would probably be pretty useful for CTFs as well, because you can see like there are a lot of different classes of attacks here. So it's pretty, yeah, wide ranging. And the last one here that I'll touch on real quick is Kube Hunter. So quick, super quick crash course on Kubernetes. Um, so Kubernetes is a system that manages containers. Containers are lightweight virtual machines, and virtual machines are virtual computers. So a container is like a very lightweight virtual computer. Virtual computer is like a computer that's fully defined in software. So it has CPU and memory disks, but they aren't physical. Kubernetes will orchestrate them for you, and yeah, don't worry about that. But this is kind of how it's set up. So each node will run your application code, and then the control plane over here is the stuff that makes Kubernetes work. And this is the control plane is particularly interesting when we're looking into attacks, because it typically has a lot of there's a lot of potential for compromises there. So we look at Kube Hunter here. This is a tool that hunts for security weaknesses in Kubernetes clusters, and it kind of goes through stages, or it'll try every kind of attack that it can at a particular stage, and whichever ones succeed, it'll move on to the next stage within that particular pipeline of attacks. So if you saw here in the MITRE ATT&CK framework, we have all of these we have this like division of what you need in an ideal attack, or what an adversary would do in an attack. This tool, Kube Hunter, will kind of go through all of the stages here and go as far as it can into your system, and then it'll tell you what kind of compromises were carried out successfully, and that'll give you an indication of where you might need to update some configs, or otherwise, bolster your security on your Kubernetes cluster. So let's look into it real quick. Let me just check the chat. Oh, we have a few questions. So Anonymous says, do adversaries require admin root privileges to carry out most attacks. Not always, but a lot of the more severe attacks will attackers will have admin or root privileges for them. But for an example, DDoS attacks or distributed denial of service attacks don't require any permissions at all. The idea of that attack is you have a distributed set of computers or clients that are connected to the app, and they're just firing requests and requests and requests until the server gets taken down. So you don't need any privileges there. You're kind of just using the app as a client may, and exploiting the fact that the app doesn't limit the number of requests that can be processed, that are processed at any given time. So no, not necessarily, but a lot of you should definitely that's definitely a big source of vulnerability. So system admins should look into making sure that root accounts in particular are very secure. Another anonymous question is if an attacker attacks a node, it would be secure from other nodes since it's a different VM. Depending on your configuration, it may not be. So you might have, for example, a privileged container, which has more privileges than a regular container would. And then something that the container or the node that container is run on would then be compromised. And you can set up different sort of connections between nodes, different trust relationships. You can also have pods. So pods run on nodes, and pods can be in the same namespace. So depending on how you've set up your namespace, those pods might be able to have certain types of communication that would leave each other open to attack. If you're perhaps a pod in a different namespace and you're trying to access one that's not within your namespace, then you might have a harder time. But it all depends on how you've configured your Kubernetes cluster. This is one of the reasons that people use clusters that are managed by cloud providers. So, for example, AWS offers a service called EKS. It stands for Elastic Kubernetes Service, I believe. And they run the control plane for you. And you just set up, I believe you just spin up an image that has your application logic. You can still configure things, of course, but they will manage mostly everything for you and kind of try to enforce some, again, secure defaults for you to abide by. Yeah, thanks for the question. Oh, yeah. Well, one more thing actually about that one is that compromises in nodes are typically not as severe as compromises of the control plane. So the control plane is what most attackers are looking to get access to, because that's going to have, if you get into the control plane, you can do a lot of things there, a lot more typically than any given node can do. But let's look into some of the different attacks here. So we have some modules here, and this is split up into discovery and hunting. So discovery only looks for certain attributes of pods or nodes, whereas hunting can actually change the state of the cluster. And why does it do that every time? Bear with me. I have used OBS before, but it's never done this before. I'm on a new Debian setup, so I'm so sorry about that. Here we are, back to the modules page. So I'll figure that out after the stream. I'm so sorry. Okay, so let's look at the hunters here. So these mostly refer to different components of the control plane. So you have etcd, kubelets, proxy. Let's look at API server. So the API server, I believe, is the component of the control plane that offers an API to the nodes, and so nodes can contact the control plane, and it's an interface to communicate between the control plane and the nodes. So we can see there are different, and this is a really well organized repo. It's also very friendly to open source contributors. But you can see here right at the top, there's some useful documentation on what this particular class of attack can do. So if this, and I think it looks like each class here is a different kind of attack that is attempted during a kube hunter run. So server API access, if this one succeeds, it means the API server port is accessible. And depending on your RBAC settings, this could expose access to or control of your cluster. So RBAC is role-based account control, role-based access control. Thank you. And that refers to the idea of giving specific roles access, as opposed to having, general like allowed access or banned access. So you can, assign into a particular role, and that role is going to have different permissions than a different role might. It's a great way to make sure that everyone in an organization only has access to what they need access to, like we talked about before. So yeah, and we can see this is just giving us the category of the attack. So if you're using a token here, then you have I think the name of the vulnerability here is access to API using service account token, and the category is information disclosure. But if you don't have a token, then you have unauthenticated access. So yeah, depending on the different like the configuration that you've used to try to access this, it'll change the nature of the attack. Um, if you have unauthenticated access, that might be a little bit higher priority for you than information disclosure, because unauthenticated access means that you don't need a token to access the API server. Mostly anyone could do it, or again, depending on your RBAC settings, maybe everyone within a certain role could do it, but still worth looking into. Then we have server API HTTP access, which means that the API server port is accessible over HTTP and therefore unencrypted. So you always want your ports to be accessible only over HTTPS, and this requires additional setup to make sure that authentication and authorization is carried out on this endpoint. Let me flip back here. I'm going to just take a look and see if there are any questions. How did I get my first internship in security engineering? Great question. So my first experience was during an exchange term. So I did an exchange at SUTD, and they have this great program where they encourage all exchange students to participate in a research project. I signed up for that. They sent me a list of research projects, and the security one sounded really cool. I hadn't really seen anything like that, like they literally had like a full blown water treatment system, like right behind a glass pane, and all of the security engineers kind of worked in the space beside it. So I thought that was really cool, and I decided to just sign up for that, and they accepted me. But before then, I had done, I believe at that point I had done 3 internships, and 2 of them were as a software engineer. So I already had a bit of background in software engineering. After that, when I went to Abnormal, that was a role for infrastructure. So again, I wasn't doing security engineering specific things there, but and I'm not sure that I'm not sure if they considered the research position or not. They perhaps they might have. But infrastructure, like the things I did in infrastructure were pretty far removed from security engineering itself, although abnormal security was particularly security forward. Like we had a lot of automation, and there were a lot of processes in place to ensure that everyone developed securely, and it was always at the forefront of my mind when I was designing when I was working on my apps and designing new services. So yeah, I guess I didn't do anything special. I kind of just fell into it. And then after that, when you have a company that has security in its name, you tend to get picked for security engineering internships um, more often. I should add that I'm in the co-op program at the University of Waterloo. Sorry, I sometimes assume that's the default, but over the co-op program, you do 6 internships, and it's a great opportunity to gain experience and earn a bit of money as well throughout your university career, which is always great to help pay off that tuition. So yeah. Uh, Anonymous asks, so are you currently doing your master's at University of Waterloo? I'm still an undergraduate student. I'm working towards my computer science degree. I don't know if that was a rhetorical question or not, but yeah, I'm currently an undergrad student. I'm not sure if I'll be doing a master's soon. I think I'd like to get a little bit of industry experience because computer science, or sorry, software engineering is very industry focused, and I want to have that experience before going back into academia. I think also it'll be nice to take a little break from school. Yeah. All right. You know what? I think unless people have many more questions about Cube Hunter, I think we're just about done there. Um, but I'll go into. Feel free to ask more questions, as they come up. But let's just review what we did today. So first we had a quick intro, and then we scaled up our security principles from single computer to thousands and thousands. Uh, then we looked at 3 different tools that help us do large-scale security engineering. All of them are very different, and there are so many different tools out there. Um, I kind of touched on this, but Clint Gibler's newsletter, TLDR is a very good resource. I think it's weekly, but the first time that you sign up, you'll get kind of an info dump of different talks that he's given and some talks that he's found to be very interesting. This is kind of like at the forefront of security engineering right now. So, including concepts like paved road, the one that we talked about, having secure defaults. Concept of shifting left is like detecting security vulnerabilities as early as possible in the security development process. So yeah, there's a lot of buzzwords, a lot of catchphrases, but it's good to kind of get a general idea of what they mean and what people are doing in the industry to implement those principles. I also used Larry Maslow's article on Kubernetes Explained Simply. Really nice images there. The article was from the iTrust lab at SUTD, and also we looked at the Cube Hunter and Atomic Red Team projects, both on GitHub. And those will be linked, I believe, in your hack packs. So that's all for me. If you have any further questions, I see Kian just asked a question. What do you think about programs like Hack the Box or Try Hack Me? Can it teach security by itself, or is it better as a supplementary to school? So it depends on the kind of security engineer that you'd like to be. I think if you're going into it, it seems like right now there's more of a focus on having security engineers with a fairly solid software engineering background, because there is that focus on automation and encouraging secure defaults. I think pen testers and bug bounty hunters will probably find Hack the Box or Try Hack Me more useful, because those programs, they kind of teach that sort of methodology of like just breaking into a system and figuring out exactly what you can exploit along the way. But I definitely think it's a very good supplementary um, program to whatever you're doing in software engineering. And again, I'm a little bit biased because I am a software engineer by trade, I suppose, because I have a computer science background. And I'll also note that it is very possible to get to be a very, very successful software engineer without having a bachelor's degree in computer science. So you don't necessarily need to go through all that um, I guess pay all that money. I really liked it because I like learning theoretical principles. But you don't need to by any means. You can um, there's a lot of boot camps and there are a lot of programs that can teach you those principles outside of school or outside of universities or colleges. All right. I think we are really over time, so I'm going to call it now. Oh, okay. One last question, real quick, from Anonymous. How would you recommend a beginner to conduct their first penetration test? Ooh, interesting question. So I guess the first step would be to make sure that your system is not being run on in production. I think if it's your first penetration test, you should probably try and like virtualize it. Separate, just run a separate instance in a VM, or you can run it in staging. I'm assuming that this is at a company, but if you're doing your own thing as well, you can kind of pull a project uh, from GitHub and set it up in a VM or whatever, set up an instance on AWS. So yeah, the first step would be to kind of set up like a sandbox for you to try things out. The second step would be so there are a few tools that you can use to perform kind of reconnaissance. You can scan all of the domains within your service that actually, you know what? If you have your own sandbox environment, you can skip that step. I think that's more applicable for bug bounty hunters, where you're looking for all of the domains that pertain to some particular some app that you're looking to find bugs for. But yeah, so figure out a way to or figure out what kind of angle you're going to take as well. So you can conduct a penetration test blind. So that's assuming you don't have any information of the internals of your system, or you can conduct it with a good amount of information. So you could research the particular project that you're spinning up and see what kind of vulnerabilities could exist there. And there are a few streamers that you can watch. And I've mainly only seen bug bounty hunters because uh, I think it's pretty popular now to kind of go that route. And it's fun to watch them as well. But they have a lot of tools at their disposal to um, sort of examine instances and detect like insecure endpoints and that kind of stuff. So yeah, I would encourage you to watch someone else do it and then set up a sandbox and kind of just poke around and try things yourself. Um, Set a goal as well. Like, okay, I want to, you know, collect this data, or I want to take this server down, and then try and do that in as many ways as you can. Another person asked, do you know if you will be having more talks in the future? So I will be giving another talk on Thursday. It's called Deep Dive into Security Engineering, where I'm going to go a little bit more into detail on some of the principles that I've touched on today and some of the services or some of the apps that we looked at here. So I think the apps will be like they'll be a little bit different. I'll have a few different ones, and a few of them will overlap with today's content. So you can be sure to check that out. That's also at Hack the North Gear Up. That'll be Thursday night. All right. I think we should call it because I'm pretty far over time here. But thank you everyone for attending. It's really great to see all these questions. Awesome questions. Keep asking them. And if you have any questions for me in particular, you can find me on LinkedIn. Should I link my LinkedIn? I could certainly do that. Yeah, just send me a message there, and I can definitely answer. Sorry. I can answer any questions that you have about the experiences I've had or about security engineering. Also, don't forget to go back to that Slido link and submit a poll. Tell us how we did. Tell me how I did. Any feedback is welcome. Critical feedback, positive feedback, anything. Um, And I would be very happy to see you all come back to Thursday's workshop where we're going to go a little bit more into depth. Um, Otherwise, have a wonderful night and have a great rest of Gear Up and Hack the North. Thank you for attending.